Okay, I'm going to look at a question that was posted by Fazile Dubes. So Fazile, I hope you're in front of your screen. This question is beautiful. It's a first paper question. It deals with geometric and arithmetic sequences and the sums of sequences. Let us get to a new page and let's see. Question 3, it says the following. 3.1 of this question says, x, 4, and y forms an arithmetic sequence. And then they say x, root 15, and y forms a geometric sequence. They want us for, I don't know, the marks are not indicated on here, but they want us to find the values of x and y. Now, they've given us some information. They gave us an x and a y in a particular sequence. They said that's arithmetic. Then they gave us x and y in another sequence, and they told us that is geometric. So let's work with that information first. What do we know about an arithmetic sequence, folks? We know that if we take term 2 and we subtract term 1 from it, it is equal to term 3 minus term 2. So in plain English, it means the difference between the two terms or the consecutive terms are equal. If that is the case, we have an arithmetic sequence. For a geometric sequence, we have a ratio. Term 2 divided by term 1 must equal term 3 divided by term 2. Then we have a geometric sequence. Okay, so let's now carefully look at what it is that we have in front of us. Let's play a little bit with this idea. I'm going to throw the T2 over, so that would mean we have two term 2's, which is equal to the 1 jumps to the right, term 1 plus term 3. And let's look at this one. If I cross multiply, I get T2 squared, which is equal to term 1 multiplied by term 3. Now, folks, those two expressions have names. The first one we call the arithmetic mean, and the second one is called the geometric mean. And we're going to use those figures that we have in these two sequences, plug it in there, and find x and y. Let's continue. Twice term 2 is 8. That is equal to term 1 plus term 3. So, sorry, I wanted to write term 1, but term 1 is x and term 3 is y. And this is the first equation I'm going to come back to. Term 2 is the root of 15. If I square the root of 15, all that happens is the square root disappears. Okay, so root 15 all squared is 15. So let's put it in there. We have 15, which is equal to term 1 times term 2. So x times y. And there's our second equation. Always bear in mind, if you have two equations to solve, you need two variables to do that. To get those two variables, they need to give you 2 bits of information, which is the case. That is what they did over here. Okay, so let us choose let's isolate the y over here. So here we've got y is equal to 8 minus x. We're going to plug that into equation 2, and then we get 15 is equal to x times 8 minus x. Now, folks, over here you can see if you multiply the x's out, you're going to have a quadratic. All quadratics, remember, need to be in standard form before we can solve them. So we need to distribute the bracket in this case, collect the term on the the left-hand side, and write it in standard form equal to 0 so we can factorize. So let's do that. This becomes 8x minus x squared, which is 15. I don't like that negative, so I'm going to hoy everything to the left. Then finally, we'll have x squared minus 8x plus 15, which is 0. That has two beautiful factors, x and x. 5 times 3. The signs are the same. They're both negative. Don't forget your therefore. So this means that x is equal to 3, or x is equal to 5. Beautiful equation there. Now remember, we're looking for a product that is 15. So if x is 3, y must be 5. If x is 5, y must be 3. It's as simple as that. So we can conclude here that y must be 5, or so that's one pair, or here y is going to equal 3. That's the second pair that will make this, or will help us find x, y, and z. Beautiful question. They gave you 3 terms. They said it's in arithmetic sequence. This is in geometric sequence. Find x and y. Okay, folks, so just remember you work with your mean. Where does the mean come from? The mean comes from the differences between the terms being equal, or the ratio between the terms being equal. That's how you find your mean. So don't go and study things like a parrot here. Just understand where they come from. They come from the basic principle that forms an arithmetic sequence and a geometric sequence. Okay, let's see at the second part. And I like the second part particularly, Fazile. So it's beautiful. In the second part, they give you the following. They tell you Sn. Now remember, S represents the sum. Is n squared plus 3n. That's the arithmetic series. Okay, they were kind enough to tell us this is an arithmetic series. And that's the sum of the arithmetic series. First term, or first question, they ask us, calculate the second term of this series, term 2. Now, folks, they gave you the Sn formula. They told you that if you add term 1 and 2 together, for instance, here, you'll have S2. If you add term 1, 2, 3 together, the n is 3 for Sn. But now, remember, if they give you Sn, this is what you've done. You've taken term 1. Why am I writing it so small there? Let me write it. Term 1 plus term 2 is the sum of the first 2 terms. Okay? Term 1 plus term 2 plus term 3 is the sum of 3 terms. So you need to think very carefully here. The first question says, find the second term in the sequence. So let's reverse 1 back from here. What is term 1? Well, if T1 plus T2 is S2, T1 plus T2 plus T3 is S3, then certainly T1 is S1. The term is standing by itself. Okay, the first term. You didn't add anything to it. So that is the key thing that you had to see here, is that you can find term 1 by just substituting into the sum formula the n with a 1. Okay, let's do that. Term 1 in this case is 1 plus 3 times 1, which is indeed 4. Okay, so now remember what they asked us actually. They asked us for term 2. I needed term 1. Why did I need it? Because I've got Sn. So I can find S2 over here. So I'm going to say S2 is equal to term 1 plus term 2. S2 will be 2 squared, which is 4, plus 3 times 2, which is 6. That gives me term 1, which we just calculated, to be 4, plus term 2. Now, folks, it's easy to see that the two 4's take care of each other over the equal sign, and we can conclude that term 2 in this sequence is indeed 6. Now, what I found beautiful here is that they did not give you any information about Tn. They gave you the sum of the series in general. That's what Sn is. It represents the sum in terms of n. And from that sum, folks, you need to unpack what the sum means. T1 is S1. T1 plus T2 is S2. T1 plus T2 plus T3 is S3. So you have access to all the terms in the sequence if you have the sum formula. Make a huge note of that, because some of you might have thought, no, now you don't know what to do. And that's what you are going to do, is literally just interpret it for what it is. Okay, the second part of this question, 3.3.2, is asking if the first two terms of the above arithmetic series forms a geometric sequence. My goodness, but they are cheeky. Calculate the sum of the first 6 terms of the formed geometric sequence. Now, don't fall in the trap here. That Sn is the sum of the arithmetic sequence. They say the first 2 terms of the arithmetic sequence, pretty much like the previous one, where we have arithmetic and geometric. So the information is going to be mixed now. But they told us term 1 and term 2 of the arithmetic sequence forms a geometric sequence. So let's write that down. Term 1 of the arithmetic sequence was 4, and term 2 of the arithmetic sequence we found to be 6. Now they say this is now a geometric sequence that we need to work with, folks. So term 1 is still term 1. But now, how did we get from term 1 to term 2? We did not add 2 like we did with the arithmetic. We need to find out what is it that we did. So in other words, we're looking for the constant ratio. It's term 2 divided by term 1, because that is what a geometric sequence is. It has a constant ratio. Okay, so term 2 is 6, term 1 is 4, and if I simplify this, it gives me the ratio as 3/2. I have my first term A as 4. Now, notice here, folks, very important, that your R value is bigger than 1. Over here, your constant ratio is bigger than 1. So you pick the correct formula. Okay? The formula we need to work is Sn A. Now remember, R is bigger than 1. So R to the n minus 1 over R minus 1. What do I have here? I have A as 4. I have R as 3/2. And n is 6. So all I need to do now is put those values into the equation. And I have my sum of my first 6 terms in the geometric sequence. So let's just substitute and see. We get 4 times 3/2 to the power of 6. I'm going to put a square bracket there. Minus 1 divided by 3/2 minus 1. Now remember, our first term is A. Okay, so I don't like this fraction. So I'm quickly just going to multiply the top with 2 and the bottom with 2. Why do I do that? Because this is a complex fraction. Okay, I can't touch what's inside the bracket. So 4 times 2 turns into 8 times that bracket, 3/2 to the power 6 minus 1. This becomes 3 because the 2's cancel. 3 minus 2 is 1. So there's my answer. All you need to do now is take out your calculator, work out what 3/2 to the 6 is, subtract 1 from it, and times that answer with an 8. Okay, so the answer, if you calculate it with your calculator, is 665/8. And that is the sum to 6 terms of this geometric sequence that they gave us. Beautiful question. Question deals with mixing up the whole notion of arithmetic and geometric. So to answer these questions effectively, you had to really know that for an arithmetic sequence, constant difference. For geometric sequence, constant ratio.